Hi there, this is Mila from Science Extra. In this lesson, we're going to look at resistors connected in parallel. In my last presentation, I had a look at resistors that are connected in series. So when you're looking at resistors that are connected in parallel, you can simply be able to come up with a very simple circuit diagram where we have a battery, and then we have the resistor, we have resistor R1, we have another resistor connected parallel to resistor R1, we have R2, and then we have another one here, R3. So that kind of connection is just a very simple circuit trying to show resistors connected in parallel. So when you're looking at the resistors that are connected in parallel, what we'll be able to observe is that there are actually junctions that are there. So we are able to see that there is a junction there, a T-junction. There is also a junction there. So once we see that kind of a connection, we simply need to know that that kind of connection is parallel connection. So now there are just a few concepts that we need to know concerning resistors that are connected in parallel. And these are concepts to do with the voltage as well as the current. So we're going to say for resistors in parallel. So for resistors in parallel, we need to know that the voltage across all the resistors is equal to the voltage reading at the battery. So if the voltage at the battery is, let's say, 10 volts, it simply means that even at R1, the voltage that will be across that, it will be 10 volts. Even at R2, it will be 10 volts. Even at R3, it will be 10 volts. So in trying to come up with a very simple equation that we can be able to use, we can be able to say voltage, total voltage will be equal to the voltage at 1 being equal to voltage at 2 being equal to voltage at 3. So that is the concept that we need to know. The voltage across all the resistors in a circuit, parallel circuit, we need to know that the voltage is just the same. Now, the other concept that we need to know is the concept for current. So for current, it is opposite. It is opposite. When we're trying to look at resistors that are connected in series, we said resistors in series, their voltage, their current is just the same. The same current at the ammeter, it will be the same current at resistor R1, it will be the same current at R2, it will be the same current at R3. But here it is different because there are junction. So as the current is flowing and then it reaches this junction there, what happens is the current at the ammeter, the current reading at the ammeter, once it reaches this junction, it is going to be split, and some of it will be able to go into R1 and we have current 1. The rest will be able to continue, and then once it reaches this junction again, some of it will be able to go, it will split, some of it going into R2 and some of it continuing passing through R3. So from there we can simply be able to see that the current reading at the ammeter will just be the sum total of all the currents in the circuit. So in trying to come up with an equation, we can be able to simply say current reading at the ammeter will be equal to current at resistor 1 being plus current at R2 plus current at R3. So basically, these are very important concepts that we need to know because they are the ones which we can be able to even use when we're given, for example, a question to find, maybe let's say the current passing through resistor R2 if we're provided with current at 1 and current at 2 as well as the total current in the circuit. With these concepts, we can be able to easily calculate. And then the other thing that we need to know is how we can be able to calculate for the total resistance. So calculating for the total resistance, we need to come up with a formula that we can use to calculate the total resistance for resistors that are connected in parallel. So it is these concepts that we need to use in order for us to come up with an equation to use when calculating for the total resistance. Now from Ohm's law, which says that the current through an electric conductor is directly proportional to the voltage, provided that the temperature remains constant, which is basically written like this: current times resistance being equal to the voltage. So now from here we can be able to say resistance over resistance. We're going to have that current being equal to voltage total over total resistance. So basically we know that current is equal to voltage over the resistance. So now it is this concept that we're going to fuse into this so that we come up with a formula that we can use to calculate for the total resistance. So as we're able to see, we are able to see that current is equal to voltage over resistance. So where we have current here, this current is just the total current. Therefore, we're going to substitute where we're saying total voltage over total resistance. So this, we put it there, and we're going to have total voltage over total resistance being equal to, here we have voltage 1 over resistance 1 plus voltage 2 over resistance 2 plus voltage 3 over resistance 3. Now, as we're able to see from here, we have seen that the voltage for resistors that are connected in parallel is just the same as the voltage reading at the battery. So therefore, from these, since we know that these voltages, they're just the same, so what we simply need to do is to cancel out by simply reciprocating this voltage, where we say the reciprocal of Vt is just 1 over Vt. So we multiply all this by 1 over V because the voltage is the same. So we cancel this, we cancel that, we divide, let me say, and we're going to have 1 there, 1 there, 1 there, 1 there. And we're going to have a formula which will be able to give us 1 over the total resistance being equal to 1 over R1 plus 1 over R2 plus 1 over R3. And basically that is the equation that we use to calculate for the total resistance for resistors that are connected in parallel. In our next presentation, we're going to look at how we can be able to solve questions to do with resistors that are connected in parallel. All I'm asking for is that you need to make sure that you subscribe. It's AM Science Extra, so that each and every time I post a video, you're going to be alerted first. Thank you very much for watching. I have been your presenter, R. Miller. Thank you very much.